Yes, hello friends. So this is the video editorial for today's GFG problem today, which is count indices to balance even and odd sums. So what the question says is you are given an array ARR, count the number of indices such that deleting the element at that index and shifting all the elements after it one position left results in an array where the sum of the elements at the even index equals to the sum at the odd index. So we can brute force this, or let me show you what the question exactly says. So for this case 2164, the question basically says is we have to count the number of indices that this array has such that on deleting this index, so let's say we delete this index, what will our final array become? All the index after it would get shifted left, right? So it would become, the array would be now 164. So what would be our odd sum? Odd sum is basically the in sum of indices that are odd. So here the odd sum would be 6 and even sum would be 1 plus 4, because see, this is the index 0, this is index 1, this is index 2. So 0 and so odd sum is 6 and even sum would be 1 plus 4, 5. Right, so 6 is not equals to 5, so this is not a valid deletion. We cannot delete this. Now let's delete this. So now what would our array become? Our array would become 264, right? 264. So if this is the array, now our odd sum would be 6 and our even sum would be 2 plus 4, that is 6. So this is valid. So this is basically answer is the number of valid indexes. This would become 1 because this is a valid index. Now if we were to delete 6, if we were to delete okay, if we were to delete 6, our array would become 214. So now odd sum is 1 and even sum is 6, and yeah, this is not valid. If we were to delete uh, 4, our array would become 216. uh, this is again not valid, right? So this makes sense. How can we do this? The key point you can see also is that the constraint is that n is around 10 raised to the power 5, so we obviously cannot do n square, and there is no need to do n square, so the constraint is n is 10 raised to the power 5. Okay. See, if we are deleting an index or an value x, okay, let's say the there would be some element before x and there would be some elements after x, right? Now we are deleting x. So if the, let's say, the total sum of the array, this is our array, the total sum of array is ts. Now the total sum of array would be 2s minus x, right? But here we are not interested in this value. What we are interested in, if let's say the sum of indexes before x, the value deleted at odd indexes is os1, or let's say os before, odd sum before, and let's say the sum of indexes or the sum of indexes, even indexes before it is es before, right? And similarly, let's find the odd sum after it. So odd sum after and even sum after. Okay, both of them we are not because we are actually deleting the index x, so both of these quantities after and before will not have the x element. Okay, that is fine. So what is the property after, like after removing it? All the odd indexes will now become even indexes. Why? Because if let's say we are for this case only 2164, right now 0123, 0123. So this is an even index now, but when we delete one, this would get left shifted by one. So like for each odd, minus one is even, and similarly even minus one is odd. Pretty simple to see. So what's the mathematical proof? Because see, in a lot of problems, if you can get to the mathematics formula, then we can derive an algorithm from it. Okay. So yeah. Okay. So what would be our mathematical formula? Is odd sum before should be plus even sum after. Because see, in the final array, this es after would become an odd sum, because after deleting it, this would become odd indexes as we saw. So odd sum before plus even sum after should be equal to odd sum, or rather, should be equal to even sum before plus odd sum after. Even sum before plus odd sum after, right? Okay. So this is a mathematics formula that we can get, and we can check this on for all each index. So for each index, we can calculate this value and check if this is true. If this is true, then we can do answer plus plus, that this is a valid index, answer plus plus, and we can finally return answer. Right? So this makes sense. If this makes sense, how can we calculate this value, OS before, ES after, these four values? See, one pretty simple property that we can see is that total odd sum, uh, total odd sum would be what? OS before plus OS after, and similarly total even sum is would be what? Even sum before plus even sum after. Right? That makes sense. Right. So if we are able to grasp these two properties, what we can do is we can traverse the array. We can keep our only OS before and ES before. Okay, ES before. We can maintain these values. Using this value, we can calculate and total OS and total ES, because see, these are constants in the array. Like the total odd sum and the total even sum are constants in the array. Using this, we can get the OS after, ES after, and then if we are able to get all these four values, then we can do this check. I think if we were able to see the code, it would be much more simpler to see or understand. Let me show you the code then. Okay. So in this total odd sum, I'm just having the sum of indexes that are odd. So I go over all the indexes. If this is an odd index, this I added to odd total odd sum. If it is an even index, I added to total even sum. Okay, that is fine. And as I said before, we will traverse the array. We will maintain the odd sum before and even sum before, and we'll do the check on the property that we saw there. Okay. So yeah, what would be odd sum after would be total odd sum minus odd sum before, and what would be even sum after? It will be total even sum minus even sum before. Now the tricky part here, or the slightly tricky part, is that we have to remove that a index I. So what I mean here is, like we can see for this test case only, that if it is 2164 and let's say we are at this index, so what would be our odd sum before? Odd sum before would be 0, because we have not seen any index, so this is 0 1 2 3, right? Odd sum before would be this. Even sum before would be 2, right? Because this is an even index and that is before it. Now what would be a total odd sum? A total odd sum would be 1, index 1's value 1 plus 4, this basically one, this index and this index, 1 plus 4, that is 5, and total even sum would be 2 plus 6, 8. Right. So what would be our OS after? Our OS after would be total odd sum 5 minus 0, 5, and our OS ES after would be total ES minus before 8 minus 2, 6. Now the thing is that we are deleting this index, right? If we are deleting this index, this has to get eliminated, and this will eliminate from the OS. Here it is an E odd index, so will actually the OS after. See, what would be our OS after? It is only 4. The after this index, only one odd index is there, so that this should be there. And because we have only removed this part is there, so this exact element has to get removed. Hopefully this makes sense. Basically, right now this part is there and we only are interested in this part, so that's why this part will explicitly remove. So how we can do this? Because this is an this is an odd index, we'll remove it from OS after. So 5 minus 1 and there's 4, and which makes sense. So that is what I'm doing in my code here. I'm just explicitly removing the ith element, and we saw that property, that odd sum before plus even sum after should be equal to even sum before plus odd sum after. If this is the case, we'll do answer plus plus, and like we'll after this we'll just add it to the before part. So if it has an odd index, we'll add it to odd sum before. If it has an even index, we'll add it to even sum before. And finally, we can just return the answer. So this works. The time complexity is O of n. We are doing just two traversals of the array. We are not creating any such array, so the space complexity is O of 1. So, thank you for watching. If you were able to understand anything, give me a like and subscribe. All of those things. Bye bye.